Hi students. Now I am going to explain the dielectric materials. So dielectrics are insulating materials. So in dielectrics, all the electrons are bound to their parent molecules and there are no free charges. Even with normal voltage or thermal energy, the electrons are not released from the valence band. Okay. So all the insulators having the energy gap is more than 3 electron volt. In dielectrics, when we apply the electrical field at high temperatures, the charges are released from the valence band to conduction band. So it causes a small flow of current through the dielectrics. So dielectrics are non-metallic materials of high specific resistance and have negative temperature coefficient of resistance. Okay, in the next slide, we are going to discuss about the fundamental definitions. The very first one is electric polarization. So let us consider an atom is placed in an electrical field. So the center of positive charge is displaced along the applied field and the center of negative charge is displaced in opposite direction. So that is dipole. So when a dielectric material is placed inside an electrical field, such dipoles are created in all the atoms inside the dielectrics. So this process of producing the electrical dipoles by an electrical field is known as polarization. So when next one is the polarizability. When the strength of the electrical field is increased, the strength of the induced dipole is also increased. Therefore, the induced dipole moment is directly proportional to the intensity of the electrical field. Mu is directly proportional to E. Mu is equal to alpha E. Alpha is the polarizability. Okay. So polarizability is nothing but the induced dipole moment per unit electrical field is. Next, the dipole moment per unit volume of the dielectric material is also called the polarization vector P. So relation between the polarization vector and the dipole moment is P is equal to N into mu. N is the number of atoms. Next one is dielectrical displacement vector or electrical flux density. So electrical flux density at a point is D is equal to epsilon into E. If the dielectric is placed in an electrical field, the polarization is also present. So now the same electrical flux density D is equal to epsilon naught E plus P. So the electrical flux density has two formulas. One is epsilon E and another one is epsilon naught E plus P due to the polarization presence. So now comparing these two equations, we have D, the electrical flux density D is equal to epsilon naught into 1 plus psi E into E. Here this epsilon naught is the dielectric permittivity of the free space. P is the polarization and psi E is the electrical susceptibility. So therefore, the relative permittivity or dielectric constant is defined as the ratio between permittivity of the material to the permittivity of the free space, which is equal to 1 plus psi E. Next, electrical susceptibility. So the polarization vector P is directly proportional to the total electric flux intensity E and is in the same direction of E. So therefore, the polarization vector can be expressed as P is equal to epsilon naught psi E into E. So where psi E is the electrical susceptibility. So psi E is equal to P by epsilon naught E. So P has the value that is epsilon naught into epsilon naught minus 1 into E. So epsilon naught E cancel in both numerator and denominator. So psi E is equal to epsilon or minus 1. So these are the fundamental definitions. Next, the dielectric classification. Generally, the dielectric materials are classified by three types based on the matters: solid dielectrics, liquid dielectrics, and gaseous dielectrics. But depend upon the working, the dielectrics are classified by two types. One is active dielectrics, and another one is passive dielectrics. So, in active dielectrics, it accepts the electricity when it is present or when it is subjected to an external electrical field. It is easily adapted to store the electrical energy. So it allows the electricity and it store the electrical energy. Okay. So the example for the active dielectrics are piezoelectrics and ferroelectrics, pyroelectrics, etc. The second one is passive dielectrics. So these dielectrics are also called as insulators or insulating materials. So when it is placed in an external field, it acts as an insulator. That means it restricts the flow of electrical energy. So